Hello all and welcome to the stream. We're gonna get into the game project in a little bit, but first, doing a little bit of debugging on the OLC community side of things. What in the world? Okay. So here we've got some kind of game. It looks like JLI key, JLIK are the controls, maybe? Temp pause. That doesn't seem right. Well, let me see. That moves the screen. Anyway. Get mouse pause. See. Is button down. Intersect. Drag. Oh, okay. What the heck? Uh... I honestly cannot tell what's going on based on that. We need something that's a bit more... let's see here. Bounds are... two vec3s. Okay. Min and max. Offset is... Huh? 6 pixels for an offset? So this is supposed to be like bounce code. It's like if we hit the top side, we're supposed to go the opposite direction. Although left and right seem to always get reversed, which is kind of weird. Let me see. Is that true? Yeah, left and right seem to always get reversed. It's kind of weird. Oh, hello. Okay. This is update. Okay. Update moves everything. Applies force, okay. Update moves everything. So first thing I'm gonna do, looks like this allows us to do key things. Let's just do one of these. Oh, there's an is active. Oh, that's for each body. Let's do this. That way we can control this frame by frame, I assume. That is not frame by frame, but that's interesting. Given delta time. Wonder what delta time is being fed in this. $16. That must be in like milliseconds. Yeah, it looks like it. Must be what's being drawn there. We have a draw somewhere. App print. App print. Looks like it's this. No, that's something else. Planets left. Okay. Text. Interesting. Is that what print? That's something else, I think. Update is... This is like something that appears in every scene. Plant scene, collision scene, menu scene. One mass body image. Next API. Maybe this. Current scene init, update render, render, current scene, render, change scene loop. Hmm. Delta time divided by 1000 because of milliseconds. Apply force at position. Checkbox collision. Are these not set right? Bounds. Why are they zeros? What's this? $500, $800. Okay, I think this one matches one. This one? But this one has a bounds. 400, 800. Max is 600, 786. I don't think that looks right. Ground is 500, 800. There's no bounds on it though. Neither of these have a... Where are these coming from? Ball? Ball. Bodies have position... Well, we already saw that. Set bounds. Hmm. I assume game object 0 is the ball? Let me see. Let's move a frame. We will ignore changes. Yes. So game object 0 is the ball, and game object 2 is supposed to be the ground. So shouldn't these be the arguments fed into there? Do we have a config file for stage loot? Like loot you would get after you complete a stage? No. Ball bounds, ground bounds. Oh, are you implying we need one? I guess I never thought about it. Ball bounds is now... That looks a lot better. Ground bound, okay. You can hard code it. I wouldn't hard code it so that you can actually change it. But yeah, that doesn't exist yet. So I remember like everything you collect in a level goes into the monster loot page, right? So stage loot is like something we'd program in, like we'd write in a file, and then that's what you get when you finish. I honestly thought stage loot meant like stuff while exploring, but maybe it's both. Because we don't really have a system like that yet. Okay. I will... Hold on. Let me do that real quick. To do... Stage loot config. Okay, it's now in there. Look at my to-do. There's so much stuff. Just keeps piling up. Anyway. Now that we got correct ball bounds and ground bounds, we can look at, I guess, random stuff. Let's, where are we? We're here. Overlaps. So we should, I forgot what the frame looked like. It looked like we were hitting the bottom at this point. Overlap Y, -83, overlap X, 121. That does sound reasonable, considering this is 200. Yeah. Overlap X, Y. Not sure what that's for. Because we calculated the overlap Y difference, but it's supposed to have a min of, or a max of 0, I guess. It's basically a max function. Min. Is this... That's scary. Min macros are scary. Shouldn't matter in this situation though. So even though I came in from the bottom, top got set to true. Let me see. So we figured this out by saying, is the max y less than or equal to the min y? The max y of the ball is less than the min y of the ground. Okay, so it's like, it's gone through the ground, so it's actually on top. I feel like this collision system doesn't account for moving, like, pixel by pixel. It's like you can jump through the wall at that speed. Like, let me see how speed is influenced by delta time. Delta time is velocity y. What is velocity y of ball at this time? It is 400. That sounds way too high. 480. Okay, we'll just go with that for now. 480 multiplied by delta time plus half of multiplied by the accelerate. Hold on, can I get a... I need a pin. Oh wait, I think it's down here. Where is... Nope. Let me do a game objects 0. Okay. So velocity y is 480, delta time is like 16 or something. Well, delta time is 0.16. Oh, I forgot we divide by 1,000. Maybe this is fine then. 480. I just don't know why we have such a big jump. Say 0.016. 0.5 acceleration was 0. No acceleration. Why do we go from... Okay, the next question is, why do we go from... I need to like track the previous... Let's track the previous position. I think that would be useful information, actually. Just add that real quick. Previous pause. Let's see if we have an equal assignment. We don't. Or maybe I typoed this. Hold on. Okay, cool. Hopefully that does what I want it to do. And we'll just take a quick peek at game object 0 here. Like this. So that should be every object updated. Should be the ball, yes. So previous pause was set 400, 200, now it's at 400, 204. And after this it should be... Yes, okay, so that works correctly. You go down here, again. I mean, it doesn't look like it's gonna overlap, just saying. Previous pause is 532, 753. It only went up by like 15 pixels. I think we're okay. So the bounds size is... For the ground is... Ooh, I can't add. That looks like 18 or so, maybe a little more. 28, there we go. So it's 28 tall. Should not have phased through that object, but it is greater than half of this. So it could phase around the object. I don't know why it's moving so fast. Like, I guess it's just really, really fast. I don't feel like this is the correct collision method for this kind of movement because of situations like this. Just been trying to get the collision to work. Okay, what I would recommend doing is whenever the position is updated for each pixel of movement, that's when you have to check for an overlap. So you would do this, let's say the ball just moved, I don't know, let's say 15 plus a little more pixels. That would be like 15 checks of collision once at each pixel. This kind of just makes sure it doesn't go through things. As for whether this is right, this is another whole question. But right now, from what I'm seeing, so here's overlap y, it's negative 88. Let me think about this for a second. What does negative 88 actually mean here? So it's like taking the max y of the ball, which is currently, should be 780. Wait, what? Maybe I'm not understanding what max and min means, because these are upside down. Min is smaller than max in the y-axis. Wait, that's why we're getting a negative number. Okay, let me see. Sure. Bounds, min, max. I mean, simple collision? Does this inherit from... I'm confused. We're using body bounds here. Object centers... Position minus scale divided by 2 times scale. Min is AX and AY. Your Y coordinates look flipped here. Negative is up, right? Max BX BY, BX BY. Why don't you open an actual Discord? Alright, whatever. Yeah, so min Y should be the top. So we would subtract, well, min Y is the top, and in normal, I guess we'll just confirm real quick. Your game engine does make Y go up, right? I'm just gonna force it up real quick. That's interesting. Um, hmm. Let me undo this real quick, just to be safe. I don't think that matters, but I'm just gonna make sure that doesn't matter. If I just adjust the position myself, everything moves down. Is 0, 0 the lower left corner then? Wait, that might explain why this is such a large coordinate. Okay. Okay, so up is positive. That's not typical, but okay. So min then is supposed to be... Min is supposed to be your bottom. This is gonna throw off everything. Min is the bottom, max is the top. But that's not what your image said. Oh, I gotta wrap my head around this real quick. Min y. So you want min y to be the top, but min y is currently your bottom because if you add, you're going up. But you're treating it... Okay, you want to use min y as like the max, but call it the min. Okay, that's how we have to think of it. So min is just up. Min doesn't mean whichever is larger. Min just means whatever is up. I feel like that really should be switched, but we'll just think of it that way for now. Min is the top. Max is the bottom. So min is the top, which means min is larger, and max is smaller. So I'm just gonna flip it for now, because it just seems really backwards. So min is now minus, which means it's going to be closer towards 0, 0, and max is now positive, which means it's closer to... I feel like... I really hope this isn't used anywhere else, because that will mess up everything else. I assume this is relevant only for collisions. What is this? Dragging. Oh boy. Hold on, I'm gonna do a proper... Let's actually refactor it then. There's a lot going on here. Max 2, because max is actually another variable. Max 2, min, and then max. Okay. There, that way it actually changes everything. That's probably better. We just make sure everything still functions just like before. Okay. Looks like it. This still does its weird thing. Oh wait. These keys still do its... Yes. Okay. That looks correct. Alright, let me think about this some more now. Game loop. Nope, not game loop. Game scene. Update. Okay. Ball bounds, ground bounds are now, well, bounds are just easier to conceptualize. Let me get into a collision again, real quick. We'll go a little faster. Let's do that. Okay. This one will probably go onto the top, but we'll see in a second. So now min is actually smaller than max. In the... Wait. I should probably do the same for the x-axis. So we can think of min as actually the smaller component of it. Min should always be smaller than max. in both components. Oh crud, that probably messes with everything. Alright, hold on. Why is it like that? What? Why is the positive axis? Is the positive axis? I guess I'm just confused. What purpose does having the larger one be? Well, I guess before the larger one was in max, but now it's in min because I had to flip them so that the y made sense. But now the x doesn't make sense. Oh my god, it's just forever ruined. Oh my goodness. All right, I just have to accept that we don't really care about the x right now, I guess, but really we should later on. All right, let's just focus on the y's here anyway. So I have to think of the x. The min x is actually on the right side, and the max x is on the left side. But the min y is on the bottom, but the max y is on the top. The max. Okay. Wow. This is like a super brain teaser. But anyways, what is this even doing? So we want to get the overlap by taking the max between either. I guess it's just really hard to understand what the intention here is. I would say overlap should represent. Like, we obviously need the overlap to know how far back to go, but to calculate the amount of overlap, we want it to be, I guess, a positive value. I think that's like the intention is how far have we gone into the object, but it should always be a positive number. So to me, that sounds like more of an absolute value thing. But let me think about this. So if we used what we're calling now the bottom of the ball, and we're subtracting it from the top of the ground. Do I have my thing? Yes. Except it's not working. Alright. It's always fun. I always forget how to reboot this thing. There it is. So the bottom of the ball. Oop. There we go. And the top of the ground? Let's say ground was here. So that's one possibility. That's if we're coming in from the top. So you would do that minus that. So that's one scenario. The other scenario is the bottom of the ground minus the top of the ball, which in this case would yield some number. Let's see. It's this minus this. This is smaller than this. So it always yield a negative number. If it's yielding a negative number, it's always going to return 0. If we did it from the top, it would be ball bounds min y minus this, which is also a negative number. So you always get an overlap y of 0 here, using that statement. So the way we would fix that is by flipping the two y items such that we always get a positive number going into the block. Okay. So let's do that first. Now, even though these say max and min like this now, like this actually makes sense because the max would be the larger number in the y component only. We have to remember that. The x component makes sense because these are flipped already. But even if they were the other way around before, I just refactored these. So technically in the old code, this was correct because min used to be the min, but then I guess the x's were wrong because the x's... Wait, is that true? If I flip to these two, I flipped the x's... Oh, right. So I think in the old version of the code, the x's were wrong, probably, for the same reason, because now it's the opposite. Let me just look at that real quick, because for min x is on the right-hand side. So if you're to take the right-hand side versus, say, the ground, which ground bounds max x is over here, so you did this, which is a positive number minus this. So right now it's correct. But before it would have been backwards. So in the previous iteration, the x was flipped. In the current iteration, the y is flipped. But in either case, one of those two were backwards. So now overlap y would actually return a number, and then we can see what happens from there. I think ideally we want, because it looks like down here we're doing directional checking. That's what I assume is happening there. So hopefully, because I see if it's the top, you're going to subtract. If it's the bottom, if it's adding. So we don't care if this is negative or positive. We're always setting it to a positive number, because this is effectively a max function. Or not a max function. This is like a... Well, it is a max function between... It's either going to be a max of 0 or a positive number. So let me run this code again, and we'll make sure overlap y is now positive. Technically, overlap x should be positive too. Okay. So overlap x is positive, overlap y is positive, so we're in good shape. We're going to use either of those. Now, let me think of the other... Is there another scenario? I don't even think this statement is required then. We should be always getting a positive number out of this. If we're not getting a positive number, we should throw, because something went terribly wrong with the calculation. We should just crash the program, at least for now. That would tell us that we actually did something wrong here. It should never be negative now. Let's go here again. So now we're here. So to calculate the top, I guess we're determining if we hit it from the top or the bottom now. Now, I already mentioned that maybe the speed is going to make it go too fast. Let's see here. Right now, the previous position was 766, and now it's at 784. We compare it to the ground. The ground's top is at 800. So I think, theoretically... Wait, the ground's bottom... No, the ground's top... Actually, I don't know what position... Position represents center, right? That's what we established. Okay, so... I have to look at bounds, actually. Bounds is... Yeah, bounds tells me the position of the top. Which in this case is... 794. So let's see. If I were trying to figure out collision here, and I was trying to figure out if it was bottom or top, I would use the center of the object I was colliding with, which would be the ground center. And then I guess I would determine if the top bound was past the middle point. The top bound being... Alright, let me think about this. If I were trying to write this with an overlap, I would use the center point of whatever I'm checking, and I would say, okay, here's ball coming in, and then it's gonna hit, right? This is actually way smaller than the ball actually is, but I would say I would be using the top point here, and I would say, okay, how does the top compare to the center? If it's below it, we have a bottom collision. And then we compare the bottom and say, okay, is the bottom... Wait. Well, what did we determine? Did we determine... We also need to know if it's the top or bottom inside the box. Only one or the other should be... Maybe both could be? Let me think about that. Maybe we should just use the centers of both objects. So maybe if we use the center of both... If the center of this is less than or greater than the center of this, we know it's a bottom collision. But if the center were like over here, we know it's a top collision. At least we're just going to assume that for now. So that's what we should do. We should just use the center points to determine that, because both objects' centers are, well, in the center. Or both objects' positions are in the center. So that's what I would do here. But here it looks like we're comparing bounds. Let me see, let me just run through the logic of that real quick. So here's ball bounds, or here's box, here's ball, going this way. So top is if ball bounds min y, which we established was the bottom, is less than, so we have to remember positive y is this way. So is less than the ground bounds max y, which is currently up here. In this case it is, so it's considered a... oh wait, and then there's an and statement. So ball bounds max y, which is the top, is greater than or equal to... So... higher than ground bounds min y. In this case, it thinks it's a top collision, based on those two statements. Let's do the bottom checks now. So we're doing the ball bounds min y, which is... excuse me, max y, which is the top, has to be less than, below, the bottom, which in this case it's not, so that would already fail. So in my opinion, this statement needs to be reversed. So let's reverse it such that top is actually referring to bottom and bottom is referring to top. In the context of how it worked before, it would have been, let me see, if it was before where we said, oops, I didn't mean to do that. Where min used to be the top here. And so it used to be bool top equals the min, which was the top. And positive y is still positive y. That doesn't change. We said ground bounds max, which was the bottom at that time. So was this less than this? That was false, so it was not top collision. So because I swapped... Wait. But I refactored everything. I remember that. So the mins used to be the max. So in the old code, it used to say top equals ball bounds dot max, which is what we have now, but we have established that that is for a top collision. Yeah, it used to say bool top equals ball bounds dot max y, and max used to be the bottom. So it's going to be the same thing we just said, right? So before, ground bounds max y used to be min y, which is the bottom, and we say it's min. So it was correct before, and then it flipped when I flipped the min and max. That doesn't make sense, because it should have been the exact same logic. All bounds max y. Anyway, this is what we would expect here. Yeah, rebuild this. So we have bottom is true. So when bottom is true, we're going to add the overlap to position y. I think we have to subtract now instead of add because the meaning of that is reversed. So we're going to subtract to make it go back to where it was before. And then we're going to reverse the velocity. What? Overlap X is clearly wrong. Let me see. How? 135. Well, so this is always positive, right? So it's always going to move to the right no matter what. So the overlap X... I guess we have to figure out what this... It also moved a lot more than I was expecting, actually. Via subtraction... we should have the exact amount we need to move. At the very least, after this movement here, that might have just been the lingering frames afterward. Not sure. Eh. No, I missed it. Very good. Hmm. Put you here. I think... Not sure what's going on there. The overlap X can't possibly be that large. Alright, let's see. Let's just see this again. Maybe there's multiple collisions. Maybe that might be possible. That's really the only explanation right now, because that's not 100 pixels. At least in my eyes, it's not. Let me just... Yeah, so I literally just hit continue, and we're in this still. So it thinks there's another collision. Of the same amounts. Why are we... The only way we would go in here is if this was true. So, why is this true right now? Oh yeah, so there was this, plus offset thing, which sounds very, very janky. Let me think about this. So, collision X would be if max X is less than or equal to min X. So less than or equal to is concerning me, because if we set exactly to where the overlap amount is, then it's possible that we're going to hit this again. So we're probably not going to use less than or equal to. We might also need to look at this offset thing, because that looks really janky. So if we were comparing our ball to our box, let's do collision X. So the max X, oh, I had to do brain mental gymnastics again. The max X is smaller. At least I believe it is. Let's just go in here real quick. Where's my call stack? Oh, we're not actually in one of these. Let's just go in here real quick, because we're probably still in a collision with it. Body A, that looks like the ball. Body B, that is definitely the ground. Okay. So max X is... the X component is less. No, that's not true. The max component is greater. The min component No, the min, wait, B, look at B. Yes, in the X component, the max is less. So this might be backwards, but so we're first seeing if the max of the ball, the X max, which is over here, of the ball, is less than or equal to the min of the box, which it is, plus some offset. I don't know why the offset there. Plus 6, question mark. And then a min x, which is this, plus some tiny offset, is greater than or equal to b max, which it is. Hey there, Zyberwolfie. Thanks for the raid. Welcome. Welcome all. And then collision y. Oh, let me just see what we got out of this, just while we're at it. Collision y was true, collision x was false. What did I forgot what we were doing. Collision x was false there? Wonder what that, what? This plus offset is greater than or equal to max x, which should have been true. I mean, it looks true to me. Well, our collision was over here, but in that case, that should have still a max x. Oh wait, this would have been. Are these backwards? Max x is less than or equal to min x, which it would have been even if the ball was here, and b min y, or excuse me, a min x. Am I thinking max x being? Oh gosh dang it! Max x is less than b min, and a min, which is over here, is greater than max x. Something tells me that collision x should have been true here, but it wasn't. Am I just thinking of the wrong things? Alright, now we're gonna do this. Those. We got these. Okay. Remember in the X component, the max is actually the min. Don't get confused. It's pretty jank. The jank levels are pretty high. Okay. So A is the ball. Again. So ball. Actually, let's put the ball where it currently is, just to give us a better visual. It's right here. Alright, ball. A max has to be less than or equal to B min. B min's over here. Wait a second, why does it say A max is 890? Oh, this must be like the after collision stuff. I didn't think about that. The ball's actually, according to this, over here or something. This is after like 4 collision ticks. I forgot. Let's restart this real quick. This looks correct though. Like I reviewed the logic and that looks right. What about Y? I gotta check Y, but it looks correct because it's inverted, which it should be, because min is the bottom, positive Y is this way, and a min Y is, let's say the ball was here, so we're checking this was less than or equal to this, which is true, and a max Y is greater than or equal to min Y, which is true. So that is also correct. So I don't think anything's wrong here other than that offset. But I think we should review why we have multiple collisions, because after one collision, there shouldn't be a collision anymore. Like, we should have bounced off the object by now. So we're gonna start here again, because this is the only time when we have collisions. So something... Hello? Why do we have a... I haven't even done anything yet. What's going on? What is this? Oh, okay, this always runs. Duh. How about we only break point when they're both true? Or when one is true. How about that? Okay. You... What? Why is there a collision? What are we... What's colliding? What is this? $370... What is this thing? There's only 3... Hold on, we need to go back one level. We're only checking this with the parameters, so it has to be the ball and the box. We're colliding since the beginning of the game, apparently. Okay. Let me think about the implications of that for a minute. I mean, right now... B max... is 400... I mean, the numbers check out for the X position, just saying. So both have to be true for a box collision. Oh, okay, I'm dumb. The return is and. So we're overlapping in one axis. So I meant to do and here. I think I was overthinking this. Okay, redo. And we're good. So I need to see what happens on the second collision tick, right? Because first collision tick, we're good. That should happen. Fine. But why does the second collision tick occur? Okay, that's good. Next breakpoint. So now we're here. This is after one tick of collision resolution. What I should expect to see is the Y position of the top of the ball to be at the Y position of the bottom of the box. That doesn't seem to be the case. It looks like the ball is at 787. That's the top of the ball. The bottom of the box is at 786. So somehow we didn't end up with a clean collision there. Okay, let me redo this. Offset is for X on... Oh wait, there's an offset for... Why is this here? It's so jank. I'm removing it. It's just gone. It makes 0 sense to me. The comment literally says, it feels right. Okay, next. Next. Alright, so what does this look like? 792, 786. Okay. Yeah, we're not getting like a clean like hit against the... So I'm gonna go here, and we said we had an overlap of 80 when the bottom of... What? Oh yeah, we're not using this anymore. This can go away. I want these two. Ball bounds, ground bounds. Okay. So the overlap being 80, what was it? 80 point something is very, sounds very large. Like, I don't think that's returning what we want here. The only way I get that number is by taking the min of ball bounds, which is the bottom of it, and the top of ground bounds. When really the amount of overlap should be like the bottom of the ground and the bottom, how much, the difference between the bottom of the ground and the bottom of the ball. That should be what the overlap actually is. This is like the inverse of the overlap. So it should be ground bounds, but depends on the orientation too, right? So I guess the max is to say whichever is larger, whichever side is deeper into the object, but you need to compare the same Y components. So you need to compare the bottom of the ground to the bottom of the ball, or the top of the ball to the top of the ground, to determine how far in it's gone. And I would argue that's the same for X. Let me just think about that for a second. If we were comparing the right side to the right side, yes, that would give us how far in we are into the object, and the left side to the left side. That makes more sense. So the overlap value is not quite what we expect there. Okay. Okay, so that collision is good. The amount of overlap is now 47. That sounds way more sane. Let's see. We assumed it was a bottom collision. It was. 47 would be the bottom of the ball, which is 738 minus the bottom of the ground, which was 786. So after this, the Y position of the ball is now at 779.258. We've already changed it, right? Yeah, we have. If it's a bomb collision, we subtract the overlap. 779 doesn't sound like it's outside at all. Alright, hold on. Let's do this again. For some reason, it's like not subtracting enough. Where's my cursor right now? Oh, we have an exception. Oh, did we throw? We threw, I think. Why did we throw? Oh, this is backwards. Okay. How did we end up negative there? Just me changing these? I took the... I took the left side or the right side of the ball minus the right side of the ground. So it's whichever is greater. Is one of these necessarily guaranteed to be... It's possible that we end up with no overlap, right? Let me think about that. If we end up with no overlap, then both of those would have had to be... Or one of these is reversed, I think. Let me see. So, yeah. One of these is definitely reversed. Maybe they're both reversed. I want the left side of the ball minus If it was overlapping, the left side of the ball would be greater than... Oh, maybe we do opposite sides. But hold on. Why doesn't that work for y then? Because y should be a similar scenario, no? Because to find out overlap, I need to find out how far in the left side is versus the left edge of the other object, assuming we have a collision on the right-hand side. So I take the ball bounds minus the ground bounds to get how far in we are. That doesn't sound right. To me, it should have been how much the right-hand side of the ground is. The right-hand side of the ground, which is max, which should be to the right of the ball. So to me, this seems like the correct play. Why doesn't this work for y though? Maybe I'm thinking of this weird. Because it's like... Alright, the colors are now reversed. If I wanted to know... Yeah, I would do top and bottom in both cases. I have to. That's the only way you get the amount of overlap there is. Or if the ball was on the side here, you would do this versus this. That's your amount of overlap. So that makes sense. Yeah, that's how I'm supposed to do that. It's... Well, we're kind of beyond the collision checking aspect. We need to get how much overlap there is between the boxes. So left side and right side of... Left side... Excuse me. So we're assuming the left side of the ball is less than the right side of the ground. And here we're going to check the opposite side. So I think this is the way it was before. It was min x. Yeah, it was ball bounds min x minus min x. Or max x minus min x. And overlap y was... If we want to know if we have a collision on the bottom of the ground, it would be min, or... Yes, it would be the max of the ball, which should be farther up because y is positive, or y up is positive, minus ground bounds min x or min y, which means if it was a top collision, the top of the ground would be greater than the bottom of the ball, and that's how much overlap we would have. All right. So let's do that. Seems a little preemptive, but we'll go with it for now. Still have a throw here. This time overlap x was still negative 118 in that scenario. I guess it would help to know which collision it is. This is... What is this? Max X... This is for a right-hand side collision. And this one's for a left-hand side collision. So in both scenarios, they ended up negative. I mean, that makes sense because that's the only way we would get a negative number out of this. Let's take a look. Right-hand side collision says negative 175. Ground bounds max was 400. Did I reverse the right and left sides? I think I... Oh yeah. Max is actually the left side. So this is wrong. We have to compare the right side of the ground to the left side of the ball, and the left side of the ball to the right side of the ground. I forgot, it's reversed in X. It's very confusing. Okay. Right side. Alright, now we end up with positive numbers. But yeah, that's why I threw in that throw there, because we know this is always supposed to be positive. If we get a negative number, we want to know about it. That way we can catch those easily. So now we're here. We haven't done any movement yet, but we know the overlap Y was 83. Let me see if that sounds reasonable. What kind of collision was? It should have been a bottom collision. 83 was the overlap. Not sure how we get that number actually. Is that really the case? I don't know about that. Ball's at 772. You know, now that I'm looking at this, why... If the ball's center is 772, why are the bounds so weird? It's like 14 in one direction and 42 in the other direction. That is weird. Like, at this point in time, the ball has already moved due to velocity reasons. The bounds... Do the bounds just not get updated? Alright, let's think. The ball is moving up, so positively. Is the difference between these... Let's see. So its previous position was 758. It moved to 772. At 758, this would have been 28 down-ish and 28 up-ish. So it sounds like the bounds are actually being the bounds from the previous frame. Well, that's no good. We should always use bounds that are on the current frame that we're checking collision for. So let's see, is this all... What does all this do? Check screen collision. If drag, where does the bounds get updated? For all objects. See get bounds. Okay, that's just something. Probably the I assume this is like the whole, the goal of the game that I accidentally hit the very first time I tested the game. Ball intersect. Okay, yeah. Drag. This is for dragging controls. What is this? Check screen collision. Check for collisions with left and right screen boundaries. Okay, that's for edge of the screen. Where do... Is it just at the very, very beginning? Let's go back to update. Update. Apply force, set position. See simple sprite. Okay. Just updates the graphics, I assume. Apply force. Where do we update the bounds? Let's find out. Bounds equals new bounds. Okay, so we call set bounds somewhere. Body set bounds is in get bounds of simple collision. So we must call this somewhere. Set collision. Oh, that's what set collision mask does. Okay, so ironically, get bounds actually sets the bounds. So that's kind of a fun name. Consider renaming that. Set collision mask, though, is named fine, I guess. So we call set collision mask, which changes the bounds. And we call, I remember seeing it in here somewhere. There it is. So this happens in render. That's interesting, because in my opinion, the collision masks are related to the physics of the game. So I would want the collision masks updated. Wait, why are there two lines? We're updating it for both the... Okay, the ball and the our object. So every time we update our position, this would be the best time to also update our collision masks. Depending on, I guess, ideally, the collision type would be stored. Oh, that's interesting. I didn't even think about that. This is supposed to be a circle collision, so I wouldn't even use like a rectangle to rectangle collision in the first place, but we'll just assume they're rectangles right now. But it would look something like this. Game objects is this. Let me see. This one's a body. So I would do bounding box, I guess, for now. I'm just gonna fill that in because it needs to be. That's what I would do. Wait, what is this related to? What's C? C here is... Actually, I don't know. Wait. Render? C... What's a C? What are you? Oh, your simple collision. Your simple collision instance. Where do you exist? Is it just in here? Oh, it is in here. So that would have to be passed down. That's kind of annoying. I guess we'll just do it outside of it for now. Sure. Set collision mask to this body, and we'll just put whatever for now. It really doesn't matter, I don't think. Actually, let's see if it matters. Oh, there's draw functions in here. That's interesting. So set collision mask doesn't set the collision mask. Well, it kind of does, but it also draws stuff. This is one of those scenarios where one function does too much. Get bounds actually sets the bounds. You're also drawing the collision mask using this function, so it's definitely one you need to separate out because it does too much. And this should be a property of the bodies themselves. Now I forgot what the argument was. Oh. It was some enum, simple collision. Simple collision. We're just gonna assume everything's a bound. Well, now that since this draws stuff, I actually need to call this in another place. It's probably gonna do weird stuff. Since this draws stuff, so I'm actually going to. Okay, I'm going to, yeah, real quick here. Every collision, or yeah, every body needs to have its own instance of storing its, so it calls set bounds. So this is really set bounds, even though it's get bounds. Set collision mask just get bounds. Let's see, these accept a body to draw the collision quad mask and the collision circle mask. So we need to store a collision mask type for every object. Every object should know what their collision mask looks like. So I'm just gonna do that real quick. I keep forgetting the names of this thing. Okay. Not you, I need the header. make use of my screen space real quick. Okay. Simple collision. Collision mask type. We need one of those as something a body should store. It should know about this. Collision mask type. If it doesn't, simple collision, collision mask type, collision mask type. We'll just default it. Simple collision bounding box. We'll go ahead and we'll just assume everything's a bounding box right now. We're not even using the circle thing realistically, but circle to rectangle collisions are a little more annoying to deal with calculation-wise, so I can see why it was preferred to do a rectangle collision. So when we draw, I think it was right below this, we have to do, is this per game object? Yes. So we do game objects, or we do draw collision. So this was based, this had a switch before, and it was going to be based on what the type was. Collision mask type, within case, bounding box. I'm just gonna do a using here, so I don't have to type this out. Do you not like that? I guess you don't like that. Oh, it's not an enum class. Alright, whatever. I'm not gonna make an enum class, because then I probably have to go around and change a bunch of things. What? You were not supposed to be in my clipboard. So if it's a circle, I think we did like draw quad something. I should probably just refer to the old code. We did, wait, not this code. It was all in here before. Here it is, I'll just take this. Mask type. Game objects I. Collision mask type. Simple collision. Collision mask type. No, we don't need that part. Then we had these. These are probably inside simple collision as well. Are they... Do I need the instance? I probably just need the instance. Okay. Then we need the bodies. Like that. Okay. So this function, I mean, we don't need that argument anymore, so I guess I'll just remove it. We just do get bounds. So collision mask without this. Should be good there. Good, good. I'm gonna refactor this real quick. Set body bounds. Oh, that's interesting. There's a circle to box collision here. Anyway, I would recommend, if you haven't looked at it already as well, there is a nice little util that the One Lone Coder community has been working on. And it's literally something you can plop into any, like, project. It's not tied specifically to the OLC Pixel game engine. It's the OLC Util Geometry 2D header. The community has been working on this a lot. I've contributed a little myself. It has a lot of functions and it's very flexible. It allows you to do point, line, rectangle, circle, triangle, and ray collisions and intersections with each other. And it also gives you overlapping information. It gives you intersection information. So like if two rectangles intersect, you can know what points they intersect at. Very, very powerful. You're not allowed to import stuff? Oh. I mean, that's fair. But like, I do notice it's like basically kind of raw. You literally have OpenGL calls a little further back here, so I can see. I see that. Set collision mask. Just I guess just something to keep in mind, I guess. If anything, at least as a reference. But like, I think for the most part I saw... Well, I don't know where these came from. If you did these, then props to you, because it's hard for me to conceptualize these things, the collision functions, but yeah. Set collision mask. Whoa, what was I thinking of doing here? Oh, right, we have to set it when... Let's see here. So we need simple collision the instance. I ended up doing this outside because the instance exists inside of here. And we don't need this argument anymore. Okay. So with that, the collision mask now updates every frame when the object itself moves, which is ideal. So we're not using the previous frame's collision mask to determine collisions for this frame. Where... I want to delete this, but for some reason I scrolled. Okay. Alright, let's run this again. Now the position information should be correct, assuming I didn't goof something, which I did. Simple collision needs to be defined. Let's see if that's allowed. That's not allowed, because this is including body, so if I include simple collision, we would have an infinite header recursion. So I'm moving collision type, just real quick, to a little header. I'm just gonna throw it in here. Collision type. That way we can include it. We can throw it in a namespace. I kind of like that idea. But then again, it's pretty verbose. Like, I would even just... I don't think we have to avoid name collisions here, really. I don't even know if this needs it, to be honest. I don't think it cares. This one does, though. Yeah, I'm just gonna simplify that for now. And we're gonna have to change it here as... or no, in the CPP file as well, because now this doesn't exist. Wrong one. Okay. So where are we breakpointing? Where's my cursor? Oh, it's over here. I forgot we have many windows open now. So I just skipped that one. Let's look at... Well, that doesn't look right at all. Did it just not... Alright, hold on. Did it just, like, not update or something? Like... We have a collision before anything has happened. I haven't done anything yet. Hello? Okay. I guess we have to look at... I just realized that we're getting a collision right at the start. That should not be happening. What is A? A is... Oh, okay. I guess A and B are not set now. Why would that... Why would that happen? I broke it all. A and B not being set. Does this do something to that? Set body bounds. Takes the body and just... It just grabs stuff. So it doesn't modify anything about body. Right? We gotta throw constant there just to make sure that's the case. Yeah, it definitely... Oh, wait. It does do something. It does set bounds. Okay. Let me undo that. Set bounds... Bounds equals new bounds. I mean, that shouldn't affect anything. Okay. Let me think of my changes real quick. Let me just rebuild just to make sure there's nothing glitchy going on there. Just making sure we eliminate that possibility. Interesting. Wait, A is being passed in as 400, 200. Is is debug just being dumb? Set by... Oh, wait a second. It thought this get bounds was actually set body bounds. Uh-huh. I see. So get bound... Wait. Oh, this is gonna throw me for a loop. So originally get bounds did get the bounds, but it also updated the bounds. So did this return something before and I just missed it? Alright, hold on. Because I had literally just modified this function, right? To... Oh, it was my refactoring that did it. It thought this get bound... Okay, so it's just... That's just refactoring faults. Get bounds. Get bounds here. So this is an entirely different function that somehow got renamed. So we need to fix all this now. Oh, that's ugly. I should have looked at that more carefully when I did the auto refactor. Because there's only one place where set body bounds is supposed to be used, and it was that original get bounds function that was only tied to this one thing. So let me fix this real quick. Oopsies. Yep, that's a pretty big oops. Anything else? So there's only one place where set bounds should be called, which is during that update function. Set bounds, set bounds. So these are get. This one's get. And get. More gets. Everything is a get. Except for that one spot. Which should be right here. Set collision mask, which calls set body bounds. And that's the only place where that should be called. Oh goodness. What a mess. Be very careful with auto refactor, because dumb stuff like that happens all the time. Okay. This is still not returning the right thing. Why are you not returning what I want? Turning bounds, okay. what are your bounds? Your bounds are 0. Okay, so something's not. Do they have to be set at first? Okay, hold on. I just thought about that. If getBounds was what called it at first, and it was done in a draw loop, then when I first I guess I need to update the bounds first before updating the object, and then I have to update the bounds again. Let me think about that. Because at this point, the collision mask hasn't been set. So it's like when the scene is initialized, probably I can use this. Maybe it's best to just do it on... Okay, yeah. We'll just... This, what's this called? It's not game object body. Just do that for now. That way it is set up right. Because objects aren't initialized. I just realized that, so... okay. I'll go like this. Okay, so let's see if we now get the proper collision mask to use. This is now populated, good. We go here, the overlap is 81. So, since the overlap is 81... Okay, now the ball bounds is centered on the ball. I can see it's about 28 down and 28 up. So, perfect. We now have the correct collision box when we're doing this collision function. So that's not a problem anymore. The only thing is I still disagree that it's 81, because if that was the case, like just looking at the like if it's a bottom collision, we would expect the top of the ball, which is 788, to be compared to the bottom of the ground, which is 786. So that's like a 2 pixel overlap, not an 81 pixel overlap. I don't know where this 81 is coming from, but let's see. So we would have said ball bounds max y minus ground bounds min y. But oh, it's the max function doing it, I think. So I think the logic should be, first we find out if it's a bottom or top collision. Then based on that, we figure out if the overlap should be comparing from the top or the bottom. Because see, this right here returns a 2.53. Oh, is that like a const expression, or is it... Wait, has this always been a thing? Oh my god, I never knew this was a thing. Wait, that's such a cool feature. You can highlight something and it shows you the calculation. I never knew this. That's crazy. Okay. Wow. Can I multi-highlight and hover? Oh, doesn't work. That's still crazy though. Yeah, we want this one. This is the correct calculation right here. But we're not getting it because we're just... So what overlap we used is based on what side we collide from. So the logic should be, if we're colliding from the bottom, actually we can even do it down there, since we already have that if statement. The overlap y becomes this, if it's a bottom collision, because that's the only way it makes sense. So the nature of this collision code is starting to reveal itself now. This is always the... In my opinion, this is always the cool part of, like, analyzing code, is, like, you eventually discover what the true nature of the function is supposed to look like. As for the x, that's... I guess we don't care about the x, but we might have to care in a little bit. So... Well, it should definitely not be negative. I I do think there's value in still checking for that. Okay. So now we have detected where we have a bottom collision, so we go down here. This has already happened, so where is the ball now? The ball is at 757. It makes the ball bounds be at 800. Well, actually, the ball bounds hasn't been updated yet. I just realized that. So it's like every time we update the position, it's like the collision mask changes. We won't know if it actually worked until we hit the next frame. So I guess we'll just go to the next frame. But that's really interesting because what if I wanted to do more stuff? Now, see, we're even using the bounds right now, but this is no longer accurate. So in my opinion, since we always have to update the bounds, since we rely on it when we change the position, anything that changes the position should be calling like a move function or something and providing like what the new position should be, whatever that would be. Like either a move function could be relative, so like you could move overlap x comma negative overlap y. You could do an absolute one if you want, like a set position or something, but that way when you call the move function, it will also update the collision mask every time. So you always, because right now we're, I guess, get bounds never returns the actual bounds it was at. It's returning some bounds it's stored. Maybe there's some value to that, but it feels like it doesn't work right now. It's just like a misleading value. I'm gonna do it here for now. Because then we can see where the new collision mask would be for the next frame, even though eventually I'm gonna go to the next frame. I'm just thinking like, if you expanded the game, I feel like it would be valuable to know where the object now is than where the object once was. So here, we look at the collision mask. Well, this is old stuff. This got copied, actually. I didn't think about that either. But if we look at the new mask, let's just look at it real quick. Our new one is... So we can see the max y, which is the top of the object, is now exactly lined up at 786 to the bottom of the ground. So that's actually perfect. That's what we want. I don't remember if I removed the equals, but I believe we need to in this scenario. Let me check that real quick. Get collision. So I left in the equals. We need to remove that, I think. But then again, the overlap y would return 0. I just think it's like counterproductive to return that there is a collision if you're lined up exactly on the box. Because the goal is to line up with the box, right? To have that perfect pixel collision. But I don't think it should be detected as a collision. At least I wouldn't see it that way. So now, after this, I guess we're kind of done breakpointing, because now this returns what we want. We can kind of see what the results of that look like. Hope I still have this one in. Oops, get rid of that one. So yeah, now we have to think about the x, because the x still is not quite correct. So we'll look at that next, but now at least for y, it resolves proper. So that's y done. Yeah, the x should be similar. It should be a similar idea. Check if you have a left or right collision, and then adjust the y or the x based on that. But since it's bouncing off as well, let me think. You're doing a reflection. If you're hitting the... if you're hitting the bottom, then obviously you reflect off the y-axis. If you're hitting the left or right side, you're reflecting off the x-axis, but not the y-axis. But right now, we're just assuming we're always going to be bouncing off of the x. So how do we know that this is only an intersection along, like, in every scenario, right? No matter what the ball bounces off of, it's always going to bounce off of, like, one edge of a box. If it was over here, it's coming in this direction, then it would bounce off that side. There never should be a scenario where a ball bounces off of two sides at once. I think one side will always resolve first. So that's something we have to keep in mind. Maybe if you really want to get into the nitty gritty, like you ended up with one of these, whichever side is like has more overlap, I guess you could say, then maybe we'd bounce off we decide we want to bounce this way or something. I guess that's a decision to make later on. That's like in the details of it. But in general, we should assume there's always only one side a ball approaching a box can bounce off of. Even if we have multiple collisions, there's only gonna be one edge we bounce off of. So I feel like the velocity changing will be dependent on that. But it's simple enough for us to write up whether or not we have a left or right up collision now. We can expand on this. I just have to keep in mind the min and maxes of the x's are inverted. So we're going to have to change that. I'll replace min with max 2, max with min, and max 2 with max. And I end up with min 2's. Nice. Wait, this didn't make any sense. Hold on. Goofed. So I replaced min with max 2. That didn't work. Hello? In selection, I replace max with min. Oh, I see. I'm just gonna call it temp then, or something. I see where I went wrong here. Replace min with temp, replace max with min, and replace temp with max. Okay. So let's not worry about the velocity aspect just yet. We'll resolve that later. We'll go if left, else if right. And it's kind of the same idea, just with x's instead of y's. These two, I believe, will also be reversed, naturally, since their meaning is opposite. Make sure we have no negative value here. That wouldn't make sense. If it was overlapping on the left side, we subtract from x. If it was overlapping on the right side, we add to x. And that should resolve the x. We're still not dealing with velocity stuff yet, but we'll get there. So let's see how that works. So that should snap the edge at least to however much it's overlapping. Well, that'll put it in one of the corners, wouldn't it? So the collision with one side thing actually comes into play already. We only collide with one of these sides. We have to decide which side before we continue. Which is interesting because now the overlap x and y kind of is a factor before we get into all this, which is probably why it was out here to begin with, because it was supposed to be used for that. So based on whether... we kind of have this like codependency thing going on though. It's like, okay, if we have a bottom and a left collision, as an example, then figure out if the bottom collision or the left collision is the one we want to work with. If it's a top or a right collision, etc., etc. So that's really interesting, actually. We first have to figure out which side we want to resolve, and only resolve that one side, because we don't want to snap the x of the ball like to one of the edges of the ground. That doesn't make any sense. We only want to interact with one side in total. So I guess I'm gonna leave it. I'm not gonna try to integrate it with the movement stuff right now. This down here is movement. So we're just gonna, I'm gonna hide it away so we're not thinking about it real quick. But what you do want to think about is just this part right here. So if we got a top and a right collision, then we need to determine, are we doing right or are we doing top? And then disable one of those. We should only interact with one. I think the easiest way to do that would be to get both overlaps and see which one is greater and use that. So we would compute both the overlap y as if we were dealing with top specifically. This can actually go out here. With the overlap x based on whether or not we're dealing with a right collision or a left collision. Why are these the same? That looks wrong to me. Did I like not account for the others? I think when I copied this, pasted this in, I didn't account for the other side. Yeah. But this code's already changed. I should make like a... I should have forked this so I can commit to it real quick. I need like a... Let me do that real quick. Because I'm about to dig into like something else, so I want to commit what I have so far. I'm just going to set the remote and do a force push. What? It's not repos. Oh, it's source. Repos. Always forget the source folder. Game test, I think. Woo! Wow. Oh, no wonder when I pulled it was so large. All that should be git ignored. But I digress. It was just probably a quick little thing. Permission denied. Oh, yeah, we definitely. I don't care about that file. But yeah, ideally that doesn't. All right, hold on. Let's not do that actually. Uh, changes not staged for commit. Did that not work then? Let me see. No change. Oh, it says no changes add to commit. Okay, good. Wait. All right, let me do this real quick. Because there's stuff that should not be added in here. Um, Visual Studio, Microsoft, there it is. Just do that. That should help. Git add dot git ignore. Why did I type cd? All right, now what do we got? Might be better to do in here. Let me see. We're gonna ignore all the OB. I feel like shouldn't .obj be part of this? Yeah, it is. I think it's not. Let me commit the git ignore first. That probably would help. Stage changes. Yes. Anything else I deleted? Complex camera 2. Okay, yeah. I mean, that makes sense. I'm just gonna commit the git ignore first. Oh no, it's supposed to ignore OB. I guess they're already tracked. That's probably why. So we have to now untrack them. Same with all this. Guess I can't do folders, but we'll do that. Everything else looks okay. Untrack items. Okay, now it looks a bit more sane. Now I'll commit what I actually intended to commit, which is modify Y collisions. Well, before okay, let me get rid of this real quick because we were at this aspect of it before we moved on. So there was also kind of a refactor here, a little bit. Move collision masks to be a property of game bodies, and adjust collision code to work for Y overlaps. Yes, so we'll do that. So that's good. And now put this back, and we can go from there. I just need to save my work because I may need to reference stuff from the past. So that's good. All right, back to this. So I believe this is wrong. Overlap Y for the top should be using the bottom. It should be using the top of the ground minus the bottom of... Wait, that looks correct. Is the bottom wrong? Bottom should be using the top of the ball. Oh, yeah, they're invert. I don't know, my mind just like couldn't put two and two together. I need to flip these two then. That's what I'm missing here. It's yeah. It looks so similar that I couldn't see the difference. So this should be the right side of the ground versus the left side of the ball. The right side of the ground is further to the right than the left side of the ball. So we end up with a positive number, yes. Okay, now that that's correct, I need to bring these up here. So left and right. So that's what we're looking at here. We need to determine which side to disable. So we say if overlap X is greater than overlap Y, then that means we're gonna do a right collision instead of a top collision. If that's the case here, I guess in either case we disable the top, and then we have an else that says we disable the other end instead. So we're looking at something like that. And we would do the same, but for bottom. And for bottom, the overlap Y changes. Whoops. Okay, so after this, there should only be one of these four that is true. So if that's not the case, we did something terribly wrong. Active sides is 0. Active sides plus equals bottom. Top. Well, actually, I'm gonna do it this way. It's probably clear. Active sides is not equal to 1. I'm just gonna throw here. That way I know I did something incredibly dumb. So with only one side to resolve, we only care about that one aspect, and now we can bounce the ball also in the correct direction and only adjust the side we're interested in. Because the other side is going to naturally resolve if we move the edge of the object to another edge of the ground. Because it's no longer going to be in collision with that. Yeah, I'm just not sure about these yet, but the velocity of the X will definitely become inverted. If it was left, it should be bouncing negatively now. If it's on the right side, it should be bouncing positively. Okay, so... resolve sides. Let's see what happens. maybe greater than was the wrong choice because it chose the left side there. So it should have chose the bottom there. I guess whichever one is smaller, because the overlap X was clearly larger than the overlap Y, so it did choose the X. But I guess it's which one is smaller. Because if we have less to go back here, we want to bounce off that edge instead. I guess smaller makes more sense. So we'll go for smaller instead of larger. Okay, so far so good. Let's go over here. Then we'll do one of these. Not what I was expecting. Okay, let's think about that for a minute. I guess that's just not the... Yeah, that's definitely not the correct approach, because just comparing distances doesn't give us a... It doesn't give us, like, a directionality. We're looking for, like, a directionality here. I think the easiest way I've resolved this in the past is, instead of thinking of it in terms of both components, do it one component at a time. So if we were trying to move like horizontally into a wall, well, not horizontally, if we were moving into a wall like in this angle, we would be moving both left and up at the same time a little bit. And we would choose to resolve it in one direction first. Like if we went up here and checked for collision, obviously nothing would happen. And then we would try for the left side and we might hit something, and we already know what direction we're checking for that collision from. So I think that's the key. Is we do one direction at a time, and we already know what direction that movement is, and then we do it in the other direction afterward. So we are doing both like a left movement. In that scenario, it would have been a left movement and then an up movement, which would have always meant a right possible collision and a bottom possible collision. But I guess possible collision is the key thing. Like, both could happen, and both could end up causing the ball to change axes. So maybe we do resolve it in two directions. Like, this else statement doesn't make sense anymore. We do want to resolve it in both directions. And that, yeah, that makes sense to me. But I think I was just confused because before we were doing like the velocity change out here independent of what happened with the collisions. So I think that makes sense. It doesn't make sense to disable one side per se. It's just if we're overlapping, period. Invert the direction we're bouncing in. The only issue is when we bounce off of like two corners. So what I need to do is, after we've calculated one side, like let's do Y first, we need to resolve a collision mask again, then check if we're colliding in the other axis, because we've already moved, so we have a new collision mask to check at that point. So before doing anything else, oh yeah, this is a copy, so we're gonna... I'm assuming this wants to be used like in other scenarios, so I think hard coding this doesn't make sense anymore. Like, I assume the arguments here want to be the same as the arguments here in all scenarios. I'm not going to actually write the new function for now, but I'm just going to assume that eventually this is what the intention is. So I'm going to call it body A and body B, and those will be the arguments used going forward. That way it's like prepared to be inserted into a function for checking later. Hey there, Magnaroon. So here's body A, and here's body B, and then I'll replace all of these with body A and body B, so this is more generalized now. Game object 0 becomes body A, and game objects... Oh, I typoed that. Did it? Oh, okay. It just... Case sensitivity in the find field is fine. Or case unsensitivity. Yeah. Switch statement? No, we don't want a switch statement here. It doesn't make sense. We don't have like an enum. No, it's not faster. It's literally the same thing. It's just going to be compiled down to the same thing. Compiler figures out the faster thing. You don't. You're not stronger than the compiler. Lost my train of thought here, so... Set collision mask for body A. Do... Right, so we have to change these now. The bound stuff, I guess all these ground bounds and things... Let's, rename all this now. Yeah, so that's what I was getting at. Instead of ground bounds, we're doing body A get bounds. Oh wait, no, it's body B we're actually comparing here. It's kind of interesting, but it shouldn't really matter, right? Yeah, it shouldn't really matter which one's which here. I guess body A, so body A is the dynamic body, and body B is the static body. If we really want to get down to it, that's what this is. So I could definitely rename it to that. This would be the static body. I kind of like that because it describes better what we're representing with it. And this is the dynamic body. You want to see what the compiler can bench? Oh my god, I don't know, man. C++ compiler is pretty advanced. It's got some tricks up its sleeve. These want to be body references. Also const. In theory, it should be const. It shouldn't be modified. Yeah, I'll throw a const in there. So checkbox collision for both bodies. And we're going to get rid of these. And ground bounds becomes the static... Wait, did I invert these? I did. Gosh, dang it. Now I have to rename static body to test body and then change it again. Dynamic body is actually the static body, and then test body is the dynamic body. Okay, now that that's finally all resolved, we can say ground bounds should be static body get bounds. Wait, yes. And ball bounds should be dynamic body get bounds. It does look a little messy. I kind of don't like that. let's make a reference to these. So dynamic body bound. Maybe even simplify this down to D body. D bounds. Kind of like that. And S bounds. Dynamic body bounds. Forget the comment. I think the comment is supposed to go on top. Oh, no, that's fine. It likes it. S bounds is static body, get bounds, and dynamic body is... Yeah, I just don't like that's too wordy. It looks way too wordy if we're just trying to read it. Static body get bounds with S bounds. And dynamic body get bounds with D bounds. Alright, cleaner. Oh, yeah, these can't be const. We do change the positions here. Fair. That code should work the same. So active sides needs to be 2 now. Well, that's not true. It could also be 1. So this check goes away. Resolve sides is not really a thing anymore. And... yeah, so after we move and we snap, we should always only have 1 velocity change. Really. Alright, let's try it. Let's do this collision first. We still execute both, though. That's the problem. Oh, we have to redetect it afterwards. Right? We have to know if... Wait, I do. That's what I do. I set the collision mask, then we check... Oh, wait, we have to... We have to do this again. Right. But now it's a reference. I guess I'm just going to copy it then. That would make sense. Because I have to change it now. Either that or I put it in another scope. I kind of like that better, actually. We scope one and then the other. Trying to think why I still have this right-hand side, left-hand side collision thing. I think that was just for testing. I don't think it's necessary anymore. Anyways, yeah, I feel like I should just scope these two because they're technically, like, separate. So we'll do that. And we'll have one in here like this. Okay. Yeah, we have to update the bounds again to do the left and right checking, because it shouldn't be colliding anymore after that. Overlap X is now gone. It's still doing it. I wonder why. Like, we shouldn't have a collision after this, so I want to see... I guess if we're in here, we're assuming we have a collision, but then there shouldn't be another collision. I guess we have to do two collision checks then. That's really what this is asking for. Because we shouldn't do the other side unless we still have a collision. Then we do care to resolve it. But this should have resolved one collision here. So we do it again. I would say after the fact. To determine if we have to do the other axis instead. Now, is it possible for it to be both? I don't think so. I feel like I'm missing a... What's this supposed to be? 1, 2, 3. Okay. Looks right. So it should be an else statement. If we end up colliding vertically, we resolve that component. But then... No, that doesn't work. No, that's dumb, because if we're colliding horizontally, that would still occur too. I guess... If we resolved it vertically, and that still caused a collision... You know what we need? We need, like, the direction of the collision. That's really what we need. Yeah, that's how we figure out which side it's colliding on, I think. So let's say we have this rectangle. And if we threw in some kind of, like... Let's say the ball was here, right? Then we can obviously see that if we were to draw a line from here to here, using the center points, that it should collide with the left wall here. Whereas if the ball was down here, then we can see with our eyes that it obviously should collide with the bottom wall. So this angle, like this angle of incidence, is actually the key, I believe. Especially for this. Since all the positions are centered, we can use the angle to figure out which side we actually care about resolving. And that's how we determine it. Okay, so as far as I remember, ATAN 2, it's funny because I complained about this last time I was using this, but ATAN 2 in our scenario is actually helpful here, because ATAN 2 normally is for a positive y-axis, so this actually returns the correct values in this particular game system, since positive is actually up. But in my games, since I use Pixel Game Engine, positive is always down, so ATAN 2 always returns the inverse of what I actually need here. So in this case, when we use ATAN 2, if we get anything between quarter and negative quarter pi, we're on the right side. Anything between quarter and 3/4 pi is top. Anything between negative a quarter and negative 3/4 is bottom, otherwise it's left. So we're going to use ATAN 2 here to figure that out. And it actually works here, because if we had an inverted coordinate system, all these numbers would actually mean the inverse of them, which is really annoying to deal with. But here it's conveniently works. So I need to go back to having left and right next to each other again, because that's what we're going to do. Okay. And instead of using left and right like this, we're actually going to compute it using an angle value. So these can go away, or these can all be false by default. I'm just going to call this the incidence angle. We're going to point from the center of our static bound box or static body to the center of our dynamic body. So I just call ATAN 2 F here. And we want the differences in... Let's see, is it going to be... I think we have to point to or towards. So it's the dynamic bounds y minus the static bounds y. And the dynamic bounds, oh, I think we typed pause there. I forget exactly. Oh wait, that's just the bounds. So we need the position of the actual object. Dynamic body position, yeah. Dot x or y, and the static body dot y. Same for the x's. And then if the incidence, we can do the absolute value of the incidence angle. Is it fabs? I think it's fabs. Yes. If incidence angle is less than or equal to 1/4 pi. Is there pi? Does this macro, where does this macro come from? App settings. What is this? Oh, cool. It's actually part of the thing. That's cool. Okay. I like it. This means we are dealing with the right side. Or right is true. We have some else statements here. Next we're checking for if it's less than 3/4 times pi. That is the top side. We're not going to do absolute value here. Yeah, because we have to know which side. So this is specifically less than 3/4 pi. That's top. If it's greater than negative 3/4 pi, it's the bottom. Otherwise, it's the left side. Alright, so that should give us which direction we actually care about pushing the object towards. Because the pushing the object part is already done. It's just which side we actually care about. Whoa. That's weird. Did I do it backwards? Oh, yes, because if we... Or maybe... Wait, what? That's a right collision. Maybe... Alright, I guess we're breakpointing now, because that definitely should not have happened. Let's see. We should have gone bottom here. Value of bottom is still false. Top is true, though. Really? Hmm. Not what I was expecting, but let's take a look at the object positions. We have 473, 760 versus... It could be inverted. Maybe I just did it backwards. Let me invert these real quick, because I think it's pointing the wrong way. You're pointing inverted. I should have actually checked the angle, but it was probably just inverted. Standard trig. I mean, is it really trig? I'm just using a function that does trig. I don't know if I'd call that trig. Oh, I should have checked the incidence angle there. Something's wrong. Or my logic's wrong. Let's see. Incidence angle was 1.3, which is a little less than half of pi. So it should have been somewhere around here-ish. So it does think it's the collision or the incidence angle is above us. So we're comparing the static body's y minus the dynamic bodies y. Okay, real quick here. I want to print out... I assume I can just print here. Maybe I can't, but we'll try. Where is this? Still don't know what this is supposed to be. Prints text to screen at XY coordinates using color R is red, green. Using the past glut font. Well, let's try it. Maybe it'll give us something useful. The reason why I want that is because I need to see what that incidence angle looks like. Let me just do a test here. Testing. Is that what you want? Oh, you want a const char? Okay, well, that's a const char for you. I don't see it. Let me try something small. Nope. Nothing. Okay. Well... console... Wait, do we even have the console right now? We don't. Okay. Real quick here. Just gotta do that. Hopefully I didn't screw anything up by doing that. Crud. No main. Oh, it wants an actual... Wait, does it not have main? Oh, it's a win main. This looks like it just creates its own window though, so we don't actually need to use that, I don't think. So let's just move it into there. Okay, so now we have a console. That way I can just print out stuff real quick. So I'm going to print out the incidence angle as we calculate it here. And we can just move our mouse around and see what happens. Well, actually, I need to first get what the... I guess we're moving the player, not the mouse, but same thing. Okay, so right now it's 1.4. Oh, that does sound wrong. 1.68. 1.55. So, yeah, it's pointing backwards. Let's change that. To be the other way. I believe I had it this way before, just didn't know if that was the wrong thing. Let's see. Okay, so that sounds correct. Let's go over here. Should be close to... Yeah, it should be close to pi at that point. So... Now that I have that correct... Let's look at why the incidence angle is not... Or this... I guess next we have to see what we get out of this. So I'm actually just going to print out the values of all of these. Standard bool alpha. Yeah. Left. You have 2 questions, okay? Bool alpha cannot convert from bool to iOS base. Oh, it's just a parameter for these. Whoopsies. Haven't used that one in a while, so wasn't quite remembering it. You'll ask in Discord? Oh, but I had to check Discord, dude. Oh, I don't want this anymore. Man, you're gonna make me look at Discord. I mean, it probably helps you, like, show the code and whatever, so that's probably useful. Well, it's point to top, but why is it point to top, I guess, is the question. So we get top when the incidence angle is less than 0.75 pi. Oh, so even if it was negative, duh, we have to have some more restrictions to this. Because we're not checking for... Well, top is when it's greater than 0.25 pi. Yeah, because it's not absolute value. I was relying on the absolute value thing before. It needs to be less than negative quarter pi here for bottom. My issue is the nodes. Okay, got the bottom correct. Let's go over here. Bounce into there. Okay, that's right. And then we got the top. Whoa. Why is my dragging cursor over here? What? Wait, does it wrap? Hold on. Something's wonky with the edge of screen detection, but we'll look at that in a little bit. I probably broke it, but we'll see. All I wanted to do was see what happens now with the all sides, make sure that's working. I guess I need to take a look at the edge of screen collision too. This way. And we got this one. That's not quite right. It gave us left when it should have been top. Oh, you know what? It has to be... Ooh, I didn't think about that. Okay, so what it should be is the angle to the point of collision based on this. So what should have happened is we should have gone top because the point of collision here should have been somewhere along this, like... So we have to point to here instead of pointing to the object itself, which was more like the angle to the object. Hold on. Let me think if I can explain that a little better. It's like, so if the object's here, right? What is the angle to the object? Well, right now it's 45 degrees would be like here. Wait, I have a freaking pen. 45 degrees would be like this, right? So technically, this ball is currently in this quadrant, so it thinks it's a left-hand side collision. So we're actually referencing the wrong angle there. What we really need to do is when the ball touches down... All right, let me see if I can move the ball real quick. All right, so when the ball touches down on this collision edge here, we need to check what angle, like the should I use the center? That's what I have to think about. Do I use the center of the collision of the bottom of the bounding box to compare to the center of the object? I want to say yes, that does make sense to me. And then that angle, or that position, wait. I think there's something else going on here. Let me make this box really big. When we're talking about like angles, a 45-degree angle would obviously hit the box way over here. It wouldn't even, like, the actual angle we're interested in is at the edge over here. So I think we have to introduce some, we actually do have to do some trig to figure this one out. Because a rectangle is obviously not square, so you can't use a 45-degree angle. You have to use whatever the angle is from here to here to determine that bounds instead. And I mean, these points are known. So like you start from the center, you go to one corner of the rectangle, and you end up with some kind of angle. So let me just variables. Let me use ABC, that's more traditional. Okay. Usually C is the hypotenuse or something. It's usually how it goes. So if we wanted this angle, we need to do the sine of A over C, right? And that would give us what angle we have here to determine what the range of that can be. But that's from here specifically. So it's like whatever this value we get, let's say I'm going to convert it to degrees and just eyeball it for now. Let's say this was like 56 degrees or something. Then the actual range of this would be 112 degrees total. Like for the whole thing is 112 degrees. Because we just add them together. And so when we're doing this comparison, it would be like, we know this would be 112 degrees as well. And then finally we have these two sides where if we take these, we get, what, 224? So 360 minus 224 is 136 divided by 2. It would make both of these be 68 degrees. And then based off that, that is what you would use for angles. We would convert this back to radians, of course. We're just using degrees because it's easier to think about, I think, for most people. And we would say, okay, get whatever angle it is to said object. So if we go back to our original scenario where the ball was colliding right here, here's the center point of the ball. We get some angle here. It's clearly, I should have drawn it more exaggerated, but let's say the ball was here or something. This is clearly more than the 45-degree angle. Like here's 45 degrees-ish. So this would have been on the left before, but now that we're using the new quadrant, which is, do I have a cyan? I swore I had a cyan. Oh, here we go. This is the actual quadrant for up now, using that new angle. So then it would be determined as a top collision instead. So that's what we have to do to figure that out. Get what the angles of all the sides are Although we really only have to get the sides of the vertical and horizontal and figure it out from there. So yeah, that's kind of the play. It's a little complicated, but that is how we would do it. Since we're dealing with rectangles here. I'm going to take a look at Magnarune's thing here while I process or I digest what I just went through. You don't know how to make a pathfinding algorithm that finds a path through the forest and that does not put move nodes into trees. Here's what you have to do. Your thing has to kind of be recursive, right? So I'm just going to trace your path you made here. So you have a dude, and your dude is walking or trying to walk this way. Obviously, I assume that's the collision box of the tree or whatever. Or maybe this is, I don't know. But obviously this is in the way. So your pathfinding algorithm said, okay, first go, I assume you said here. So your path would then become like this, right? Node 1, node 2. And that would have worked fine with one tree. But now you have another tree, and here's the collision box of that tree. And so your node ended up in the collision box of that tree. So every time you create a new node, you have to say, okay, well, is this path actually safe? Or is this actually safe? No. Now you have to start, I would say like the halfway point or something. And you have to say, okay, from here, try to path to this node. If you can't path to the node, you have to find out, can you path here? Well, that one's not safe. You have to path here, or here, I guess, if you have your big outer box. Like, here's the big outer box. So you try path to the bottom. Obviously, that's not safe, so you have path up here. Oh no, you have to subdivide your path the further you go. So then you would have to walk up here, and then you would walk back over here. The faster way would be down. You are correct. You didn't consider that we have to be greedy instead of just solving it. Well, here's what you can do then. Instead, you need recursion. You basically need to try all paths and figure out the shortest distance. So the more I guess your cost factor would be how many nodes you have. If you're going from point A to point B, your cost is 1. There's only one node. If you're going from point A to point B to point C, your cost is 2. You have 2 nodes. And obviously you can take either path. And you would add the lengths of your paths to figure out which one's shorter. So maybe this gave you 4, this gave you 6, this gave you 10, this gave you, or that doesn't make sense. This gave you 6 as, we'll say like 7, it's a little longer. And this gave you 5. If the distance to here was 9, the other way was 13, you obviously choose this path because it's faster. But obviously with more collisions, you have, I guess your cost would just be the length of the nodes. So here's your other collision box. Here's your outer detection thing. I need another color. Let's do green. That's not green. Yellow. Okay. So first thing you would do in the algorithm is what you would normally do. You try to walk the straight line, you realize there's a collision on this red box, and you're like, okay, can we go here? Yes, we can. Can we go here? Yes, we can. You do both. These are both now branches in your timeline. I'm calling it a timeline, but whatever. All right, next, you check here. Well, there's a collision, so now we have to back up to half the distance as before and start a new node here. That's still in a collision, so we have to back up half the distance again. Now we're not in any collision, so from here, we have to now figure out again, you do like a kind of line pathfinding. I guess you have your boxes again. Until we find a path that has collision, find the shortest like distance that we won't collide with. In this case, you have like this. You also have this, but that's in collision, so that's automatically invalidated. But then you can also go here, right? That's another idea. This might collide though. That probably does collide. So you would invalidate that one too. But now, here you go. You have another path here. So now you're going this way. And then you try to go in your straight line. You realize there's another collision. You do it in half. You realize, okay, you can go here, but this node already points to this, so you can't go there again. You can go here now, so you consider that line. And then you can do a beeline straight for your goal. Now, obviously, when you calculate this path, you can literally just go straight to it. So then the distances of this would be like 1, 2, 1, 4, 8 or something, while the distance here was like 6 and 7. So obviously this one would be shorter then because the total is 13, while this one is like 3, 4, 8, 16. So that's how you would do that. You basically need to create a recursive function that will slowly like cut down this line until you're not in a collision anymore, then attempt your multiple like pathfind nodes and see if they're in collision, and if they are, you have to then cut those in half, etc., etc. It's something you have to build a recursive function for. And then on top of that, you have to figure out which node is best. So you would have like multiple. Basically, consider all possibilities as valid options. If you can move here and here and here and here, you do so always. So you just have different branches, and then you consolidate all those and figure out which one's the fastest. Cutting off branches that suddenly don't go anywhere or that don't have a possible path. So that's what I would do. It's gonna be complex for sure. Okay, I'm back to this game. I'm gonna try to finish this up here because we're almost done. Like literally, the collision is done. It's just a matter of figuring out which side, which is the tricky part. Weirdly enough, I can't really see a better way to do it. You literally just have to get the angle of incidence of the center of wherever you collided with. It's gotta be fast. I mean, it is fast. Everything I just described is like, let's see, maybe a couple of quad tree searches, and like you're talking maybe 100 to 200 like checks, right? Assuming your path doesn't get too long, and if your path gets too long, you insert a like exit. Maybe if it can't find one in 1,000 searches, it gives up or something. Like, let's say you had something really, really complex and it tried searching in all sorts of ways, and then we ended up with, like, you can put a limit on it. Like, if you have over, like, 20 branches, don't add any more branches. If you have over, like, 1,000 searches, don't allow any more searches. Just break it off then. You have to add some hard limits to say, okay, don't go too far. Yeah, at some point you just have to give up, because you can't always find a path. Unless you search your entire map. You're not going to search your entire map. That'll take too long and it'll be too much. So these are the factors we have to tweak, and then we're done here. To figure that out, first we have to take our... We have to get our angle. Let's call this the... corner angle. We're just gonna do top left. I'm gonna call it the top left corner angle. It is the sine of the distance from the center to the left. We're doing center to the left edge of a particular triangle. It's going to be center to left edge of the rectangle. I'm just gonna do static body get pause dot x minus, wait a second, don't we have the size of the, we use half the size of the bounds. S bounds dot, let's see, if I do min x, which is actually the right side, minus s bounds max x, and I divide that by 2, we end up with the width of half the box. Why are there no spaces in my code? That's just how I am. Sorry. And I don't type with spaces. Oh, before I continue, let me do a quick commit. We're gonna commit, I'm gonna call this the scuffed incident angle collision code. Collision is working though. Just, we have a scuffed incident angle, that's all. Yeah, I do need to commit there because that's a good stopping point. So top left corner angle, sine of this, and we have to divide that all by the hypotenuse, which is the distance. Is there a better way I can get that? I feel like there isn't really. I literally have to do the distance from the center of the body to the corner. Yeah, there's really no other way to get that. Okay, let's see, do we have like a vec2? Yeah, we do. So we use a vec2 top left corner. Well, that doesn't help me though. I want the vec2 to represent the actual, like a vector does in the OLC Pixel game engine. It just represents some length. I mean, I guess we could use it that way, that's fine. But we still would have to calculate that distance, because that's what sine requires. I wonder, let me see. Maybe there's a helper function? Potentially? Let's just take a quick look. Ooh, we have getMag. Okay. That will work. So the way we would use this then is we would take the center. So static body get pause. Hello? Oh, get rid of that. Static body get pause. And we would subtract that from the top left corner, which is going to be, I guess I have to make a vec2 on the spot, don't I? A vec2 that uses the S bounds max X for the left corner, or the left side, and the top is S bounds max Y. So if I subtract those two, I end up with a distance, and then I can do get magnitude on that to give us how long it is, which I then take the sine of. I'm going to put sine F there. And so that should give us the top left corner angle. Let's try that real quick. Actually, I want to print that, not breakpoint it, so we can move around and see if that gives us what we would expect. Actually, it's going to be calculated once and then used multiple times, so I guess I could have breakpointed it, but whatever. Let's see. Let's just go over here. Okay, top left corner angle is 0.83. Does that sound reasonable for this? I mean, I eyeballed it to be like 50 something degrees. And what's 3.141592653588979 divided by 2 divided by 2 again is 0.78. So yeah, that actually sounds reasonable. It's just slightly over 45 degrees, which is what I estimated. So that does sound correct. We'll do a quick 0.83 radians to degrees just to see is 47 and a half. That does sound a little smaller than I was expecting though. Let me think about that. I mean, we could calculate it ourselves too if we really wanted to. I don't know. I'm kind of tempted to see what that would be. Does that really? I don't know. That feels way like it should be way more than 47 degrees. Maybe I have it inverted. Like, to me, that just doesn't feel like it at all. Let me do this in GIMP. Yeah, so if we just look like, let's just take the middle being, how large is this? This is a 204 wide image for now. I'm just gonna cut it down to the bare bones here. Here we go. All right, so 200 we'll say, close enough. This is the center. And this is the angle we care about. So if we were to take the sine of, let's see, so what's the distance? The distance of this should be, let's see, it's 100 wide, so 100 squared. What? 100 squared plus, it is 27 tall, we'll say 26, so 13 times 13, 13 squared. And then the square root of that is 100-ish. So the distance is about 100. The angle is so tiny that it actually works out to be almost 100 anyway. So that's 100. And we had draw it actually. So we have 100 here, and then, oh no, hold on a second. If I do 100, isn't this 100 too? So isn't it the sine of 1? What would the sine of 1 be? If that's actually what that is, then that's weird. Why does it just put a 0 in? How do I do this? Oh, that's sine inverse. Where's sine? Am I blind? I don't see it. Oh, okay. Sine. Why does it just fill? I'm so confused. Do I just put it first and then I put sine? Oh, there we go. So the sine of 1 is 0.01. Well, that's not what we got here. Hmm. So it's close to 0. Here we got 0.83 though. I had this minus that divided by 2, which would have given me the width, and I did the position of the body minus the magnitude of the width. Okay, so I'm not supposed to use position here. I'm just supposed to use the magnitude itself. Not sure why I did that. So I do it divide by... Yeah, that sounds correct. That should be the upper left corner. Let's see if we get a different number now. I believe we should. We got 0.11. So that angle is what? 0.11 radians 2 degrees is a 6-degree angle, which sounds way more, way less. But that also sounds more or less correct. Like what would we say this angle actually is? Like a 12? It looks almost like a 12, right? It's very, very small. So I think that is correct, more or less. I wouldn't disagree that that's a 6-degree angle. Okay, so we'll use that then, at least for now. So the next step is, well, obviously we need the inverse of that. So we do I forget here, because this is now in radians, which is kind of annoying. We need like a quick radians to degrees function. And probably back. Rad to deg. I'm just gonna pull from my game real quick. It's like 2. Just pull U2. Degrees to radians. Some nice little functions there for us. Comes in handy. Just makes it easier for us to think about. So I'm actually going to convert this to degrees at this point, because we need to take 90 degrees minus this, which gives us what our angle would be going into these incidents. Wait, actually, that's not true. This actually would be our check angle here. So top left corner angle now becomes this. Well, this is in degrees. All right, hold on. Maybe we don't have to convert this then. So if I do this, then we have to say, okay, so if it's greater than this or less than, the other side is pi minus this. So you do pi minus to get the top. So pi minus top left corner angle. And it's greater than, yeah. For the other side, it's just negative. So you do negative pi plus the incidence angle, or the corner angle. Negative pi plus the corner angle. So it has to be greater than that. Greater? Yeah, greater. And it has to be less than the negative top left corner angle, then it's bottom, otherwise it's a left. Alright, so we'll try that out. So in this case it was bottom. Here it's right. Let's try a very sharp angle of approach and make sure it still gets that correctly. That one should not have been top, I don't think. Let me think about that for a second. So it's like if I don't know, that's where like there's like a super edge case, right? It's like clearly that one should have been the right hand side. So why didn't it choose that side? Let me see. It chose top instead. So the incidence, oh, wait, absolute value, is that correct? Let me think. Has to be less than the top. Like I said, the actual angle is very, very small, like 6 degrees. Like, what does that actually look like? Maybe let's get a visual on it. 6-degree angle. I mean, to be fair, that does kind of look like our image. If we just, like, superimpose that real quick. Like, I guess it is a little larger than I was expecting. That does look correct, actually. Scale it down, we can flip it and... yeah, look at how exact that is. That is almost exact. So I would say that is a 6-degree angle. I don't think we can really debate that. It's very close. It might be a couple off, but it is close enough to where we can say that's a 6-degree angle. More or less. So I actually do agree that is pretty close. I mean, to be fair though, there is rounding error. It's actually a... What is this actually? This is like a radians 2 degrees. This is more like a... Wait, what? That is not the right number. The number was like 0.82 something. I deleted it already, I guess. Oops. Let me see one more time. Wait, it is for 0.11. Hold on. I thought it was for like 0.8 something. What is 0.11? Alright, let me take this. Is that 6 to... I think that's close to 6. Yeah, it's like 6.3. So the actual report angle is 6.3 degrees. I guess... I'm gonna output the... Well... Yeah, let's output the incidence angle again. And we can do kind of a walk around and see what's going on. Now that we know it's supposed to be 0.1 or 11 or whatever. The goal is that when we hit it from, like, say, the left side... Like, this incidence angle is definitely within here, in my opinion. So that one works. Negative 3.1 is pretty close, but when our incidence angle is greater, right? That's when we have issues. because now this is bouncing. Oh, maybe we have to use like... So here's something we didn't consider. We're using the center now, so the center is actually going to make it use the bottom here. What we really need is, I guess, the center point of collision, ideally. Something like that. If we collide with it... Like on the next frame, this is going to be inside this block in both the X and the Y axis. So there's potential for collision to be in both directions. I guess it's the center point of where we overlap. Like, here's what I'm thinking. If I were to make this larger. Here's the box. Here's our circle. So it's outside right now. On the next frame, it's going to be like this. So the angle we're interested in is actually, and here's bounding box of player. So not to scale, obviously. What I think we have to do is this box right here. Like, we technically know where the collisions occur here. And I guess we're interested in getting like the center point of this collision. Like, that might make the most sense. If we get the center point of the collision and use that as the angle. This is a very bad angle to do it from, though, because it looks like it can go in either direction. But if this was, like, further up, we do a more obvious one. Let's say it hit it from more the top here instead. So this would be like the collision box. Then the center would be right here. So we draw a line to that center point. And I think that would give us an easier way to identify, yes, we're hitting it from this side. So we should use the overlap box. And get half the size of the overlap box. Okay, so the steps would be get the overlap box, get the center point of the overlap box, determine angle to that center point, use that to determine which side. So I think those are the steps. Because when the center point is... Here's the line that determines whether we go left side or bottom side. When the center point of the collision box is down here, like say the collision box looked more like this, or maybe like this, I guess, then the collision should resolve downwards instead of left. That's what I'm thinking right now. I think it makes sense. So we do need this angle. That angle is important. we keep that there. I'm gonna add a little comment here. We use the this angle to determine the grade on which the top side versus the sides intersect. That's what that's for. But it's not enough, apparently. We also need the overlapping box itself. Which is funny, because that's kind of what we were trying to determine earlier on. It's like... the overlap between the rectangles, it's like... how do we conceptualize that? We can turn to the geometry utils file to kind of get an idea, because the overlaps function for rectangles looks like this. Or maybe not this. Let me think. If you had the intersection points of the rectangle, you could figure it out. And that was done by taking each line and intersecting it with the other line. So it's like two line intersections. I want to say this was kind of resolved earlier though, right? Before we were calculating the overlap X and Y, assuming it could be in either direction. But then the problem was we did max on it, which meant a left collision might end up being on the right side, or a right collision might end up being on the left side. So a line intersection function is this. So you would need the cross product of both the lines. And then you end up with a line. So we're probably going to use this because that's useful. And this will return the intersection points between two lines. And we need to basically check the overlaps using those two lines. Using that information, we can create an overlapping rectangle. Line intersection. We'll accept two vec2ds or vec2s. Line 1 and line 2. It'll be const, and we'll get out a const vec2. Okay, so Oh, I guess we need two lines, as in we need two vec2s, one to represent one point and one to represent the other point in any given line. So this would be like line 1.1. And then we have line 1.2. Like, we don't have a line, right? Let's see. This is a vec2 header. I don't think we have a line. Where is this located? API game test. Am I blind? Oh, right there. Yeah, I don't see no line, so. I mean, that would be like a utility you'd construct, but for the sake of this, we can live without it, I think. Like line 2.2. Because these are supposed to be vectors, which represent the differences between the two lines. So here we would do line 1.2 minus line 1.1. And then we have the cross product, so that's another thing. Cross product itself is... let's see. You multiply the right-hand side y to the x, and you multiply the right-hand side x to the y. So this is the vector, which is that. And then the cross product of the vector is... so we need to cross it with line 2's vector. So this is vec2, which is line 2. So we're going to get the cross product of vec2. So we do vec x. Do we have a cross in here? Maybe we do. I don't see one. So vec x multiplied by vec2y. And we subtract that from vec y multiplied by vec2x. Now there's no multiply. Cannot convert for... Oh. It's just me being dumb. Oh, so this is gonna modify it directly. If I just do that. So ideally I want to make a copy and modify that. So cross vec x gets multiplied by vec2y. Wait. Oh wait, this is... Oh my gosh. The cross product is a float. Okay. That makes more sense. So it's not really a vector, it's just the cross product. I'm going to change that to cross p. So kind of with a blank line, vec2. I assume these initialize to 0? Yes. So all these that say line to end is referring to line 2.2. All these that say line to start is line 2.1, line 1, so on, and so forth. Okay, then we have another one of these. And finally, if we get through all that, we can now put here line 1.1, line 1 as a, hold on, as a vector. That was vec. No addition for this. I assume the addition here just adds them to both components. So it's x plus rn, comma, y plus rn. Multiplied by vec. Oh, we have to distribute that too. To look at that function one more time just to make sure implemented it correctly. So you multiply, order of operations says this happens first, so... Yeah, if I just incorporate it, that would naturally resolve itself. So vec x and vec y. Cool. So that should give us a proper line intersection function, hopefully. I guess we could test it. Once we're in here, we should have some line intersections. So we can test... do we just test all lines? Yes, we do. Let's test all lines for intersections. That actually tells us whether we're supposed to be like a top, bottom, left, or right bounce already. Then it's just a matter of which one gives us yeah, it's just a matter of which direction we can go in that makes more sense, which is taking that center point afterwards. So we can get a box out of this afterwards. We just have to make sure that function is returning what it's supposed to. So let's just check all four. So I'm going to do... This returns a vec2. Intersection top equals line intersection. All right, so the top line of the dynamic body, we have bounds, so we can actually use that. So d bounds, the top line. Kind of already have that, don't we? If we do... Wait, that's a vec3. I assume there's no implicit conversion here. Yeah, definitely not. So since it's a vec3, we're gonna have to convert it anyway. Okay. So top line starts with max x, comma, max y. And then it goes across to min x, still max y here. Or wait, it doesn't go across. This is like drawing a line. Wait, yeah. And then the line intersection for the... Wait, don't we have to check every line for every... Hold on, how does that work for a rectangle? Let me see. I feel like we have to check every line. So here it does for every side. Do an intersect check function on L. So it's one line versus another rectangle. So what does that look like? What's a... Wait, this is rectangle to line. What about rectangle to rectangle? Rectangle to rectangle is for each side, do intersection function of rectangle to line. Which in turn... Yes, so it's a nested loop. Does a for loop on every side of that rectangle. So I feel like the process they use here is actually very much in line with what we're interested in, because we have to remember a line intersection could intersect multiple points, although ideally we're only interested in the first point, or a point. So this is like line to line, and then we have a collection of all the intersections between one rectangle versus another rectangle on all sides. So we have to provide a list of all the sides then, and compare that. So this would be like an array containing vec2s. There will specifically be 8 vec2s representing all the lines, rectangle lines. And I guess we could prepare all those. Expected a declaration. Okay. Why don't you like this? Like it, dang it. I mean, I shouldn't have to include the amount if I just fill it in. At least I thought I wouldn't have to. It's kind of weird. I don't remember that being a thing. Like, I could have sworn I could just fill... whatever. Units fighting over gang to node. Let me see.
Should I mess someone up?
I mean, if they get in the way of each other, they need to be able to, like, either push each other around or ignore each other's collision or something. Like, a unit that is standing still shouldn't be, like, a wall for another unit. They should, like, push each other around. Like, a unit that is moving should be able to push other stuff out of the way. Hi, what OS are you using? I'm using Windows 11. Anyway, I guess I'll just fill these out. So yeah, every single line of every single rectangle, of both rectangles, has to be filled out here. It would be like, here's dynamic rectangle lines, and then we have the static bodies rectangle lines as well. We'd have to fill both out, and then we would have to iterate through all of one, to iterate through all of the other, to get all of the intersections, to return them. So this is the top line. This one will be the right line, bottom line, and left line. Something like that. And then we'll do the same, but for these. It doesn't like this, apparently. Incomplete type is not allowed. Really? It's incomplete? That should not be true. Where is it? Maybe it is. I haven't really looked at it. So there's no include vec2, which is interesting. Very interesting. Okay, well, I will include it, question mark? I feel like this would have definitely needed it at some point. I just realized a lot of these are globals. Wow. Anyways, vec2. Local variable is non-initialized. What? Yeah, this doesn't make sense. I don't think it has anything to do with non-including vec2, because that wouldn't make sense. That would have caused other errors earlier. Let me see. I mean, hmm. Unless the thing's standard array is not. Let me. Oh, yep, it's happy with that one. Okay, so that was it. Great. Wonderful. Alright. Anyways, right line is... We can actually use the same points multiple times, which is interesting. I think I'm still going to keep it individual just to be safe. So this just goes down to mid-y, then bottom line is the top line, but with min-y instead. And then the left line is the right line, but with the x-axis flipped. Like so. And then it's the same thing here, but using the static bounds instead. Then we're going to iterate through each line. I is less than... well, rectangle lines size increment by 2, because we get 2 points make up a line, so we have to jump by 2 every time. We need to collect the intersections all in one giant vector. So it'd be a vector of vec2s, intersections. I guess if there's ever a rectangular collision, there are at least 2 intersections. I just thought about that. There will never just be one, because that would be impossible unless the box was rotated. But yeah, that's kind of an interesting thought there. Only if the line intersection is not blank, I guess, not equal to 0, then we care. So intersection equals line intersection between direct lines I, direct lines I plus 1, and then we have to do another for loop in here for all the static body lines. Same deal. Okay, so if intersection x is not equal to 0 and intersection y is not equal to 0, then it means we have an intersection of some sort, so we will add it to the list. Once we're done, we should have a list of intersections to look at, so I'll just loop through those real quick. And I'll go ahead and print them out for now. Is there a conversion? Nope. So x, throw a little parenthesis in there. Comma y. Alright, let's just have a peek. See how that goes. Identifier A is unidentified. Oh. I typed in A apparently. Did you see my question? I did. And I responded by saying I think units should be able to push each other. Like, if a unit is standing there, then they've obviously reached their point they're supposed to be at. So if another unit like moves towards a unit that's standing, they should push each other. Or they should push them out of the way. I think if 2 units are moving like into each other, you might have to just you might be forced to like add some like randomness to it. Like one unit should have priority over the other. Like force maybe based on like their IDs or whatever. Whichever unit intersects first gets priority and pushes the other or something. Just make it so one unit can't move. Like you have a flag or something, like it got pushed out of the way. So interestingly, nothing got printed out. Hmm. Oh, maybe Well, both should be non-zero. Yeah, I would say both should be non-zero in most cases, so... That's a little weird. Maybe this got hit? Let's see. Let's see if we just got hit early. Nope, it looks like it went all the way through. So it's saying intersections not within a line segment, I guess. I assume we're just hitting that then. Or it's not happening at all, question mark? Like surely we're going in here at least. Okay, we're definitely going in here. Which goes in here. Which goes through these. Cross product is a 0. We shouldn't have zeros at all. Vec 2. Oh, the y does end up being 0. Wait a second. That's not right. That means I fed in the wrong... Uh-oh. Yeah, I fed in the wrong information then. Because those lines would be... let me see. Well, no, if the y's were... The y's could be the same. Check a line intersection again. I see. So just to confirm, vectors should be subtracting the 2. Let me just confirm that real quick, because I'm pretty sure that's the case. Till... I remember that being the case. Vector. Yeah, it's endpoint minus start point. Which is what we're doing here. So... taking line 1's vector, you're doing the cross product of line 2's vector. Or you're taking the cross product between that and line 2 as a vector. Which I guess I didn't implement correctly. It should be x times the other's y minus y times the other's x. That looks more or less what I want. In either scenario, there should at least be some value that's different. Well, okay, so maybe the two lines I compared were vertical to each other. Like, that's another consideration, right? But if we go in order, it would be like the top line compared to the top line. Those two slopes are the same. So we should expect the very first intersection to be cut off. I think that actually makes sense. So the cross products of those two should be 0. But then we move on to the next one, right? So now we're on to j should have incremented to 2. So now we're comparing the right line to the top line. That should go further. But it doesn't. Why? I thought we're comparing top line to... Wait. S lines to... Oh wait, I put I again. Oops. Very common way to screw something up there. Very common. Alright, let's take a look again. That probably will fix everything. There we go. So we have 2 intersection points when we hit that particular block. Let's go over here. Do one of these. And once again, we have 2 intersection points. Very good. So these 2 points will be compared. So basically what we just got are 2 points that represent the overlap. So like our collision box is like this for our player. We just got returned these 2 points here. So the significance of that is we can take our upper left corner now and our lower right corner as well. And we can now form a box out of that. In fact, we can just grab the midpoint of this line right here. And boom. That's the line we use as the angle to compare to. So I think that would be best. So now that we have those, assuming we have 2 lines, we can go further. If we don't have, let's see, if we have more than 2 lines, it's fine, but we need to have at least 2 lines. I actually have an idea. This is like a check for this guy right here. If we have less than 2 lines, right? This is interesting. Then we actually throw, because that means we falsely reported a box collision. So that's really fascinating. We should definitely have at least 2 intersections at this point. Otherwise, our checkbox collision function is faulty. So it kind of checks itself. But in any case, now that we have 2 lines, or 2 intersection points, we take the midpoint of those 2 points. So, point 1 is intersections 0, and point 2 is intersections 1. I don't think we have to do a copy here, that's not really necessary. So the midpoint will be taking the differences of the x's and dividing it by 2, and the differences of the y's and dividing it by 2. 0.1x plus 0.2x divided by 2. 0.2x, 0.2y divided by 2. And now that we have the midpoint, that is the angle we're going to compare to. So before, our incidence angle was calculated. Where is that? Our incidence angle used to be calculated by the center points of both objects. Now the incidence angle will be calculated by the static body's center position versus the midpoint of the collision box that we got instead. Okay, so that works as before. Now let's try a sharp angle going towards the right here. So that looks like it bounced downward. And then let's try going this way. Huh, that also bounces downward. That's no good. Hmm. Why is collision detection your big struggle? I mean, collision detection is always a a challenge. Especially if you wanted to bounce off like in the correct direction. Because once your object, if you have like different variations in your delta time, like this isn't a fixed time simulation, right? Where you know exactly how fast something's going. Every single frame, an object might move a little faster or slower than a previous frame. So you need to always resolve a collision before the next frame occurs when you have dynamic time. So this is a dynamic time application where every frame can vary in time. So even though you say you're moving like 100 units per second, like 100 pixels per second, how one frame is happening in less than a second. And you don't know how long that frame is. So that's if you're not doing it with like a static time, then it's a lot trickier because you have to resolve the collision on the frame. So you have to make sure there's no collision. You have to move the object back by however far it collided with, and you have to figure out which direction that object has to move into. That's why collision detection is hard. If we could just tell the box, become unstuck in the correct direction, that would be great, but unfortunately that's not how programming works. That would be super nice, though. Yeah, I just have to figure out what's going on with this incidence angle thing, and then we should be good. So I'm gonna output it. Let's see if it at least makes sense. If it doesn't make sense, then we know our midpoint's wrong. Maybe I'll put our midpoint at the same time too. That might give us another hint. Oh, I should probably answer your question, Magnaroon. Well, actually, your partial question, because I think you forgot a word. You said, how much memory should my game? Yes. Also, how would you know the other unit is there? Um, so my idea is like, if you have a bunch of units, and then you have like, let's say these two units are trying to move to this one point, and they're like bumping into each other. That's like the problem you showed in your little video. They keep trying. They both need to get here, but they're actually like this one's trying to get here, and the other one is trying to get here, right? And they obviously got to go towards each other to get there. And they're getting each other stuck trying to move in the same direction. That's the scenario. When you iterate through the units, there's a certain order you do them in, right? So like, let's say you're going through your object list like this, like each unit gets processed individually, right? So the reason why you're experiencing this behavior right now is you're first processing this unit and you're like, okay, move down. Sure, it can move down. Then you go to this object later and you're like, okay, move up. Well, this unit pushed this unit down. Now this unit is pushing that unit back up. What you need to do is when a unit bumps into another unit that's friendly, it's going to mark that other unit as you can't move anymore, at least not for this frame. So you just add a little flag that says you can't move. So when we iterate through our objects and get to this object has already moved. It's not allowed to move this turn. You just skip it. That's how you have to handle that. Only one object is allowed to do something on every frame. And that way, if two units are pushing against each other, one is going to resolve before the other, and that'll naturally make both of them eventually resolve it themselves. Because once this unit has made it to their target position, then it's happy. Then this unit can push it out of the way and go to its spot too. Like, that's how you have to think about it. It's like, if two units are fighting for a spot, only one can move. Both can't make it there. Unless they pathfind around each other, which I don't think you want to do. That's a whole nother mess. Okay, so we're getting a midpoint and an incidence angle. That angle does look roughly correct because negative pi is down here. We collided with it about right here. And yeah, let's go over here though. So I would expect if I collided with it exactly like on the right side, it should give me about a value of 0. And it's actually giving me a negative 0.84. That's really interesting, because negative 0.84 is like... Let's see, what's a quarter pi? A quarter of pi is... 0.78. So it's actually giving me a little more than a negative quarter pi, which is interesting. Okay. Well, this is actually a good, like, baseline case here. If this is giving me a negative quarter pi, then I want to look at what we did wrong here. Let me just slowly, like... Okay, yeah. We definitely want to investigate that. I should have breakpointed there. Just need to figure... Just this weirdness. Some weirdness going on. Okay. Before we do this, let's see. What are we most interested in? I guess the angle itself. Wait a second. Yeah, the angle itself. But we'll just step through this. We'll see if something weird pops up. Okay, so we've collided. A top left corner angle is 0.11. That's static. All right, moving on. This is all just setting in a... Okay. Why does it just not skip all this? Okay. Entering in here. Getting intersections should now be fine. Let me just... Let's get some positions up here so we can compare. Like here's the static body. So when we're doing collisions, we should expect variables within like these ranges kinda and bring these down. Okay, so let's do our intersections. I'm just gonna skip past these. So we have a list of intersections. We got 2. They look like this: 598, 814, and 598, 786. That looks about right. It's got one that is... Oh, I think I see what happened. These intersections are 2 lines that are vertically aligned with each other. And you know what? That makes sense, because our rectangle... Yeah, our rectangle went inside of it from that edge. I mean, that makes sense, yes. If our rectangle is very small in height, that's exactly what we would expect. Like, we have a giant freaking ball. And so we got the 2 points here and here. So that does make sense. Well, this will be a rectangle, so more like here and here. I mean, that looks fine. Moving on. We just grabbed them. Yep. And then we got a midpoint. So is my midpoint function wrong? I don't think so. Wait. Oh my... Dude, I'm triggered. I can't believe it. Oh my god. That's triggering. Such a simple typo. Wow. Okay. Go back up here. Oh, we don't need to. Let's unbreakpoint these, unbreakpoint that. Okay. Let's go over here. Let's do this. Okay. Go over here. Do this. Okay. Let's go over here. Let's do this. Beautiful. I'm honestly surprised at how complex this problem actually is. It looks simple on the surface, but it's really, when you dig into it, the parts required to move things around, it actually makes it a lot more challenging. If it was just squares, it would be way easier, but it's not squares. That's the problem. Before I commit, let me remove random output stuff. This can go. Am I missing anything else? I don't think so. That's pretty much it. Let me just remove the code that's doing it like frame by frame now. We'll just play the game without frame by frame. Honestly, that code there really saved me, because if I had to make a lot of other changes just to get it to render only one update frame, like sometimes, depending on how the game is, like, you might have certain code running certain objects but not other objects. Like, luckily it was all in there. It just made things really easy and convenient to modify. So yeah. It was nice that, oh yeah, there is that. I did forget about that. I'm not sure what's going on there. That's interesting. Might have to look at that real quick. I totally forgot. But we'll do that. It's only the bottom edge too, so that's really interesting. Let me commit this real quick. Static body to dynamic body collision handling complete. So I'll commit that. Let's take a look at that real quick, just as a quick final side note, I guess. Oh, I didn't end up needing these conversion functions. I guess I'll remove those. That's not necessary. I mean, realistically, like, we're kind of in a day and age where even if you are sort of building stuff yourself, you're probably gonna reference things that other people have already done, right? Like, coming up with a line intersection function to me is just so deep in the roots that, like, unless you're a mathematician and study these things, you're just not gonna know. I feel like at that point you've just gone off the deep end. So sure, I might not be. I think it's fair game. Like, if you find something and you know how to use it, you can incorporate it into your game because you know how to use it. It's like it's kind of like a fundamental function that you just need to have for like to like get stuff done. So I feel like that kind of stuff is fair game. Bouncing off boundaries. Where is this? In given bounds. So we have point one. Oh, I like this. This is kind of cool. Let's see here. So what are we passing in? Let's get our things. So we got game object 0 get bounds. Okay. So that's the right side. And the top. Okay, so that's the upper left corner. And this is the right side and bottom, the lower right corner. Okay, simple enough. So we're seeing if coordinates x, well, what's chords? Chords is mouse pause game. Oh wait, that's the dragging function. Uh, oops. Here we go. Check screen collision. Object. Okay, get bounds again. Calculate dynamic top and bottom limit space. Okay, that's just Windows stuff. Uh, check for collision. So we're probably okay here. That didn't see anything wrong here. Let's see. Check for collisions with top and bottom screen boundaries. Bounds was object.bounds. I assume that's the player. It was. So if we want to do the bottom, we use min y. So if min y is greater than bottom limit, which should be 0.95 times that virtual height, okay. Then position y is subtracted by bounds min y minus bottom limit. I think that just wants to be an equals. Bounds min y is reflective of its position already. Well, no, that's not true, because we need to subtract it from it. Object pause y is the center. So bounds min y, how did we figure out the center? Because that's really what's important here. It's Kind of a problem. Well, this one conveniently works because the the top is literally outside. So if you did, it's funny how that one actually works because here's the top of the screen, here's the ball, here's the top line of the ball. This distance is how much you have to displace the ball this way. So when this is negative, this is like -8 or something, because it's above the screen, you just push it by 8 because you invert it. So it's funny how that one works. So you kind of just need to apply the opposite, right? So here you're getting the bottom, and you have to do, so this would be, let's say this was at position, I think it's 950 or something. So let's say this is at 960. You got a difference of 10 here. But yeah, this is at 960. So your movement up is whatever this minus this is. So you did bounds min y minus the bottom limit, which gave you 10. But you have to add it because your axis is positive. Because if you subtract the bottom of the ball, yeah, you have to add it. Let's try that. Maybe I should go slower. Come back. Wait. Oh, what? Huh? Alright, hold on. Something weird happened. Let's see. Wait, is the bottom the top? Hold on. I just realized that. The bottom is the top. Oh my god. I didn't even think about that. The bottom is the top. So I've been doing this backwards. Okay. Well, that makes sense. Okay, so we have to think about this then. Because it's... bounds max is the top. Man, this coordinate system has given me a run for... what in the world? This coordinate system has given me a... oh, my program crashed. That's interesting. I just realized it's in my taskbar too. Okay, anyway, here's our line. Ball is now we're actually looking at the top one. Bounds max, I was wondering about that because bounds min is here, bounds max is up here. So we're saying if bounds max y is positive y is this way, right? So bounds max y needs to be greater than the top limit? Wait a second, but isn't the top limit the... hold on. Top limit is... wait, so you're telling me the screen coordinates go from 0 on top down to 1000, but the game coordinates, this game engine, goes from 0 at the bottom, positive y up. Holy cow, my brain. Oh my goodness. This is like some next level stuff right here. My brain is just so confused. So object pos y plus equals bounds max y minus top limit. Yeah, that should make sense. It's just the reverse of the bottom one. But holy cow, this just breaks my brain. That's insane. But yeah, this does sound correct without actually looking at the math in detail. That's why it's a challenge. I definitely could see it. Yeah. Oh. Well, goodbye ball, I guess. Did I break something by doing this? I don't think I changed anything else. I just changed this, right? Top limit, max Y. Max Y is the top, so less than top. Hold on. So top limit is for the... Is top limit for the top or bottom? Now I'm even more confused. Check for collisions with top and bottom. Oh my god. Okay. Breakpoint time. If we hit this, we're dealing with the top. Okay, we don't. Interesting. So this is for the bottom of the screen. Okay. So it goes minus equals so that means you would use min here. And you would do bounds min y minus top limit, and you add it because you've gone below. And then this one should be for the bottom. So for the bottom, you need to compare the top y. And you need to see if that's greater than the bottom limit. If so, you subtract based on max y minus bottom limit. Do I have breakpoints? Alright, let's just see what that looks like. Woo! Okay. Let's do some more breakpointing here. At least we know which one's which now. So, bottom. It's already hit it for some reason. Top limit is 60. That's... Okay, that's fine. Bounds min is 59 there. Really? That early? Is the bound supposed to be that high? I don't think so. That doesn't sound right. Top limit is 60, really? Should it be like... Because that would mean it's like the ball is already out of bounds at the beginning of the game. I feel like that's not... That was not intentional. But let's see. Because that one feels a little more sane. It's still not quite at the edge of the screen. Top limit being 10. Like, I feel like you kind of just want to go 0. Right? I don't know what your intention was, but like, to me it feels like it should be close to the edge of the screen. Like, that just makes sense. Even then... What's going on there? The ball is not even close to the bottom of the screen. That's really weird. Go negative? Because that is surprising. Yeah, that feels a little closer. Let's go a little further, I guess. I'm just gonna set something that feels like it's close to the edge, like negative 0.1 probably feels right. Okay. So at this point, what does this resolve to? I like this feature I discovered. It resolves to negative 1.966. That doesn't sound like it should. Let's see here. Time to bust out the drawing. So here's the bottom of the screen. Here's our bowl. It just went, the bottom just went underneath the edge of the screen. So boundsmin y is less than the top limit, we have to remember. Positive y is this way. And so we want to take the bottom. And now the top limit is actually a very small number. This should be a very small number too, though. So if we subtract them, like this is like negative 110 or something, and this is negative 100, we get negative 110 minus 100 minus negative 100, which is negative 10. So if we were to add that negative 10, we'd go down even more. So we just want to go the other way. So that one definitely has to be a plus equals. Or rather, it needs to be minus equals because it's negative. Because we're below it. Yes. Oh, now it goes too far down. Now it's behaving... Huh. Hold on, let me see that one more time. Why is the screen suddenly deciding that it wants to be larger than it was before? Okay, well, if that's the case, I'll put it back to the 0.1 or whatever. Okay. I think it's because before, the bounce would occur after the position has already been resolved. Okay, now that's too high. Like, see, there's... I'm just gonna go to 0 for now, but whatever the intent was, I guess. But yeah, that seems correct. Let's look at the top now. I'm not sure about the... Oh, I don't want it to continue, but... top. I mean, that seems correct, too. I'm happy. I like it. I don't know, maybe the bottom was supposed to have that border. It actually looks better that way, with the border that was there before, or maybe like 5% or something. But yeah, I'm happy. Put back to the 5%. Fix bottom screen border collision. I did continue committing to that fork, so you're more than welcome to reference it and either work your way back to what I did today yourself, or just copy it and continue from there. It's your choice.